Good morning, good afternoon, good evening, ladies and gentlemen. In today's video, we're going to be looking at cosine law. Now, in my last video, I didn't take a look at how to prove sine law to you. Nobody really asked, but I can most definitely do that. Now, for cosine law, I do want you to understand where it comes from. So I'm going to show you how you would prove the cosine law. Okay, so let's say you're looking at the diagram below. And let's say in it you know that you know angle A. So I know this angle. Okay, I don't know angle B, I don't know angle C, but I do know this side. So let me use a different color here. So I do know, I'm going to use different colors for the things that we do know. Okay, so I know my angle, I know this side, and I know this side. But how would I find that side? So I know those sides, I know those angles. So how do I find A? Well, in its present state right now, you wouldn't be able to find A unless you split the triangle. So I can split the triangle by making a dotted line here from my B vertex all the way down. So because I'm hitting this line perpendicularly, I now made a right angle triangle with these 3 points here. Okay? Now, because it's a right angle triangle, I can actually make Pythagorean Theorem. Now, also, because I split this perpendicularly, it's like, I don't know what it is. Like, do I know what the length is from here to here? No. And you can't say it's just divided by 2. This isn't a normal right angle triangle, so it's not a perpendicular bisector. So, I would assume this is x. Okay? Now, let me just erase this so I can make room here. Okay. Oh, that's weird. Okay, there we go. Now, remember, from here to here, so the whole line is B. And from here to here is x, because I don't know what it is, and I can't just say it's B divided by 2. No, it's not that. So my other part would just be B minus x. Okay. And of course I don't know what this line is here, so let's just give it another letter. You can give it any letter you want. I'm going to call it H. Okay. So we can use Pythagorean Theorem here. So what does Pythagorean Theorem tell me? We know in Pythagorean Theorem that a squared plus b squared is equal to c squared. So if I want to find out what a is, well, you're going to have to make two equations. You can make two Pythagorean theorems here because you have two right angle triangles. So for the left triangle, you're going to have h squared is equal to c squared minus x squared. This is, of course, because I want to try to solve what h is. And, of course, in my original diagram, I know what c is, and I know what b is. Okay? And in my right triangle, so when I say right, left, I mean this is my left one, this is my right one. If I want to find out what a is, well, I can rearrange that as well. I can say h squared is equal to a squared minus b minus x squared. Okay. So now I have two equations, and I have two unknowns, so I have a system of equations. So I can use substitution here to solve for this. So if I know a squared is equal to this, and a squared is equal to this, so I can literally solve this using substitution. So I can say that instead of h squared, I can put c squared minus x squared is equal to a squared minus b minus x squared. Okay? So now you just want to isolate your a. So you want to move away everything that doesn't have to do with a. Alright? So I'm going to leave a squared here. And on this side, I'm going to move all that, which means it's going to turn positive. So you're going to have c squared minus x squared plus b minus x squared. Okay? So now that you have that, you're going to want to expand your b minus x squared. Okay? So you can start collecting your like terms. So you got c squared minus x squared. B minus x squared, I'm just going to use my nice theorem here so I can expand it quickly, or you can FOIL it. So you should have the first one squared, so plus b squared minus 2ab. So I should have b times x times 2. So minus 2bx plus x squared is equal to a squared. Okay. Now you want to collect your like terms. So c squared, there is no other like terms, so I'm going to leave that alone. So you have c squared plus b squared minus 2bx, okay, is equal to a squared. Alright? And that is how you find it out. Now, in the leftmost triangle, cosine of a, so let's say my left triangle here, if I wanted to say cosine of theta, well, opposite over hypotenuse, if using SOHCAHTOA. So by SOHCAHTOA, I'd have, well, opposite over hypotenuse, that's for my sine, sorry, misspoke there. You'd have adjacent over hypotenuse, which would be x over c. Okay, so if I wanted to solve for x, x is c times cosine of theta. Okay, so how does this change here? Now, instead of theta, let's just make this easier and say a. So another way of saying it is cosine, c cosine of a. Why? Because that's the angle that belonged to that a side. Alright? So what does that do? That allows me to change this x here. So my final form is going to be a squared is equal to c squared plus b squared minus 2b, and of course I can now put in the missing stuff there, which is c cosine of a. And that is what they call the cosine law. So, in layman's terms, what is cosine law? Essentially, let's say you're missing this side. So whatever side you're missing, you add the squares of the other two sides, and then you subtract away from it 2 times those two sides multiplied by cosine of the angle you're given. So let's see how this works in an actual example. Okay, so let's look at this first example here using actual numbers. Now, you notice in the last one I said that we have our two sides, we have an angle, so basically when you want to use cosine law, you can only use it when you have two sides and an angle, but that angle has to be in between those two sides. Think of it like a sandwich. You're making a nice sandwich here. I'm going to draw myself a nice sandwich. Bear with me here. It's going to be probably a horrible looking sandwich. So the sandwich, you have your two sides. And then in the middle, whatever you want to put inside your sandwich, make it like a vegetarian sandwich, a meat sandwich, that's always the angle. Okay? So that's side, angle, side, SAS. So this case has SAS, so you can do side, angle, side. So I can use cosine law here. Now, if I'm looking for x, if I'm going to use cosine law, so cosine law would be, in this case, whatever I'm missing squared. So if I'm missing x, then I'm going to do x squared is equal to the other two things added together squared. So if I have 11, I square it, and I add to it 9, and I square it, and then I subtract away 2 times the two things I'm given, so 11, 9, and then multiply by cosine of whatever angle I'm given, which is 28 degrees. Okay? Now, the best way to do these type of things is do it piecewise. So you want to do 11 squared plus 9 squared first. Well, 11 squared is 121. 9 squared is 81. Minus, well, you want to do this multiplication first, so that's going to be 198. Cosine of 28 degrees. It's going to give me 202 minus 198 cosine of 28 degrees. Now, I highly suggest you do not just put this all in your calculator all at once, because you will make some calculation errors if you do it that way. So that's why I suggest to wait until you get to this step here and then put it into your calculator. And when you put it into your calculator, you want to do 202, and then you want to subtract away, and then you want to put brackets around this, and that should give you a more accurate answer. Okay? Now, some common mistakes people do is that they would go 202 minus 198, and then subtract from the, and then multiply that. That's not what you do. BEDMAS. Remember, BEDMAS says you have to do your multiplications first. So you do this multiplication first. The 198 belongs to the cosine of 28. Okay? So after all said and done, you're going to get a big, huge decimal number. At this point, you don't want to round yet. You want to write down as many decimal points as you can. You're still technically rounding, but that's because you still have not finished this. Then you're going to take the square root of your answer, and that's what you're going to round up to, about 2 decimal points. Okay, so you're going to take the square root. You should get 5.2. Don't forget that this is in centimeters because of our unit. So x is 5.2. Okay? So, you can use cosine law when, as I said up there, if you have SAS, or if you have SSS. If you have all 3 sides. Because then you can use that to find your angle. And that's what we're going to be looking at next. Okay, so let's take a look at this example here. So in this example, we've got all 3 sides, SSS, and we're missing that theta. So how do you set up your equation here? So whichever side belongs to that missing angle is the one that you're going to make the whole thing equal to. So I'm missing theta, which belongs to 2.3, so you're going to have 2.3 squared is equal to the other two sides, just like before, so 1.8 squared plus 1.2 squared minus 2 times the other two sides you have, 1.8, 1.2 times cosine of theta. So now this becomes another one of those solve for the variable questions. So you want to isolate the theta. So you want to move away everything that you don't like. So what I would first do actually is do the squareds. So 2.3 squared is going to give me 5.29. I'm actually going to do 3.24, yep, plus 1.44 minus, well, 2 times 1.8 times 1.2 is going to give me 4.32 cosine of theta. So I'm going to bring these to the other side, which means they'll turn into subtractions. So 5.29 minus 3.24 minus 1.44, that's going to give me 0.61 minus 4.32 cosine of theta. So I want to get rid of this multiplication now, so I'm going to divide both sides by negative 4.32. Alright. So this is going to leave the cosine by itself. And then finally, if you want to get the theta, you're going to have to go cosine inverse of this whole mess. Okay, so you put that into your calculator. And it should give you, well, approximately 98 degrees. And I just rounded it to the nearest whole number here. And that's how you would solve for angles. So I'm going to put up 2 examples here that I want you to pause and try yourselves. Okay, so these are going to be the last 2 examples we're going to end off here with. I want you to try these 2 out, so pause the video and try them out yourselves, and then when you come back, see if you got it right. Okay, I assume now you've finished doing it, you've unpaused the video, so you want to see how it turned out. Alright, so we're missing x. So if we're missing x, that's going to be our x squared. Remember, add the other 2 things. Squared minus 2 times those things, cosine of 45. Okay? So you've got 15 squared, which is 225, plus 10 squared, 100. 100 plus 225 is going to give me 325. Minus 2 times 10 times 15 is going to give you 300. Cosine of 45. Okay. You want to start doing these calculations here. So let's pull out this standard calculator here. Now, the only downside of the lockdown is that my beautiful, beautiful calculator, a nice graphing calculator, is at school, so I'm stuck using this amazing, I'll say amazing, calculator. So, cosine of 45 times 300. Want to copy that number, you're going to have 325 minus that, which is going to give you 167. Alright. So I'm going to take the square root of that right away, which is going to give me approximately, let's go 2 decimal points, 12.94. Now, excuse me, I didn't actually put my units here, so let's go with meters. So this should be meters. Let's go centimeters here. Alright, and you're done. Now let's look at the second one here. We're missing that theta there, so if we're missing that one, the side that belongs to it is that one. So you're going to have 35 squared is equal to 10 squared plus 15 squared minus 2 times 10 times 15 times cosine of theta. Okay? So let's do this. So we already know what 10 squared plus 15 squared is because, well, I kind of cheated by making it in the other question, so that's going to be 325. And, of course, 35 squared is 1225. Minus 2 times 10 times 15, well, that's going to be, of course, 300. My pen's not working. There we go. Now it's working. 300. Cosine of theta. Let's get the cosine of theta by itself, so let's move everything to the other side. So 1225 minus 325 is 900. Let's divide both sides by that. So that's 3, well, negative 3. And let's take the cosine inverse of negative 3. So what's my theta? Well, if I've got negative 3, and I'm going to take my cosine inverse, it should give you, that doesn't exist actually. Sorry, I had to trick you guys in that last question. So the theta obviously does not exist in that case. But the steps are still perfectly good. How do you know it doesn't exist, obviously? Well, if you're going back to the past lessons with the cast, you should see already that it should definitely not exist with negative 3. But that's what the great calculator is for. The calculator will tell you it doesn't exist. So, that is the end of this particular lesson. I hope that it helped you understand cosine law, especially where it came from, and have yourselves a great day.